How y'all doing? Dial back here again. And did you know? Did you know that Go has a template engine baked into the language? Yeah, that fancy little thing that say frameworks like Laravel and PHP has like the Blade template engine. And if you've used Ruby, you probably used Rails, and Rails has like that embedded Ruby syntax for templates. Yeah, instead of using a full-blown framework, you can basically just get that baked into the language with this little text template package. Now, here's the thing to note. There are actually two template packages in Go standard library. This one, which is the one I'm going to be using for all these examples, is text/template. And there's another one specifically for HTML. Now, they have almost the exact same functionality, but the HTML one has a few extra bits of functionality put into it, specifically to properly escape special characters in your HTML to avoid certain attack vectors like JavaScript script tags being injected into your web page and stuff. Now, if we look at this, this is pretty straightforward to use. Here's an example that they have on the documentation, and here is the syntax you use when you're actually like referencing like a value or an action. You're going to be like injecting a value into your string, and it's like this double curly braces syntax. You also see this dot. This is probably the most confusing part about Go's template syntax. If you can wrap your head around what this freaking dot means within the various contexts you'll be using templates, you've basically gotten around like 90% of the headache around understanding how Go templates work. So let me just switch over here and start showing you some examples. So you'll see I have a string here that just represents a very simple template. It just says hello, and then I am injecting, again, dot, whatever the hell dot is. But I will explain to you what dot is. So if we actually want to put something in this, use this and use it as a template and then put some data into it, right? So what I want to put into let's just put my name in there. So I'm going to say I'm going to store this in a variable. Name is Donald. Now I want to actually get a template that I can interact with. So I'm going to say template error equals was a template.new, and you can name it, and the name doesn't necessarily matter. It's more if you're going to be using like multiple templates. I'm just going to call it hello, and we'll call parse. Now parse takes two arguments. It takes whatever the string representation of your template is. So in this case, it's just going to be my template string, and then it also can take in what is it? My brain's working really hard. That's it. Yeah, never mind. I'm getting ahead of myself. Yeah, it's just that. So back up, run this. So, and of course you gotta check for errors as usual, like this. Oops. I'm just gonna say log. Just do panic. Let's just panic and said could not parse template, something like that. Now, there's actually kind of a convenient way of setting up these new templates where you don't have to error check every time, if that's okay. Which is, instead of doing it like this, you can actually wrap this template.new in this convenience function that the template package has called template.must. Oops, is a template.must. I think that's what it is. And what this will do is, if this throws an error at all, it'll panic. The runtime will panic. So if you don't necessarily need to handle the error because it doesn't work anyway, this actually prevents you from having to error check it like this. So we have our template, and we want to put our data into it now. So we're going to say error equals template.execute. So we're going to execute processing this template with some kind of data. So the first argument is anything that satisfies the io.writer interface. And so just make this easy, I'm going to use I'm just going to have it go to standard out. So standard out, standard out, I think that's what it is. Okay. And then you pass in whatever the data is that you're going to put into the template. So in my case, it's just name. Oh, that's why it's not. Why are you? Oh, I can't type today. Okay. So if error does not equal nil, excuse me. Let's see. We're gonna say panic could not execute template. Okay. So if I go run main this, what it should do is should just print out hello Donald, right? Okay, there you go. So, and just to verify that, let's say if I change this to let's see, my last name, Feury, and I run this again, there you go, hello Feury. So there's a couple of other interesting things you can do with templates, and that is you can use a lot of the things that you would normally use like in while you're doing normal programming in a template, such as conditionals. You can use the range operator to iterate over collections of data, which is very useful. And so let's do that as an example. Let's I'm gonna have another template string. Template string equals. Let's see. Let's print hello if my name is Donald. How about no? Actually, we're gonna do. Let's just do if the value I pass in is excuse me is false, we're just gonna print out nothing, or we're gonna print out like go away or something. And if it's true, we're going to actually print out like hello. So let's go do like it's if dot. Yeah, we're just gonna do that. If dot. Then we're going to say, I'm just gonna say hello. Yeah, like that, I believe. And then I think you have to put end at the end of it. It's like that. And I'm going to parse it like I did before. Template equals template.must dot new hello to dot parse template string. Oops, that's the wrong assignment variable. There we go. And we're going to do error equals template dot execute os std out, and let's just pass in 0. So 0 will evaluate to being falsy, so this should not print out anything, right? So we're gonna do actually I'm just gonna throw the error away because I don't really need that right now. And that should work, I think. So let's go run main, maybe. Yeah, so it didn't print anything. Now if I go back over to it, but change this to 1, so it's a truthy value, and I run it, it printed out hello again. So let's do a range over some values. So let's have some names. A name, and it's just gonna be a slice of strings, and we have you know, Donald, Bob, Brody. We're just have a slice of strings like that. So we're gonna have another template string, and this time we're gonna do a range over dot, and we're gonna do hello dot like that. And this one I'm going to explain what the dot thing means, because at this point you're probably like, what the hell is the dot? Let's see, that should be, oh wait, no, I gotta go over here to end. Anytime you're doing like the actions like if and range, you have to actually put an end to basically say that you're done with that action. And we're gonna do template equals template dot must template dot new. We'll call it range parse template string. Throw the error away. Equals execute std out and names. So what this should do, actually, let me change this one thing real quick so it's a little easier to read. I think put a new line there. So that should be, give us a bunch of new lines. Okay, so you see that, I should put the new line up here too, but you see hello Donald, hello Bob, hello Brody. So let me explain what the dot thing is, because at this point you're probably like, I don't understand what the hell the dot is. Best way for me to explain what the dot is if you've come from a language that has the concept of this or self, it'll make a lot of sense. For instance, when you are in an instance of a class object from, like, say, Java or something, this would refer to like the actual object that's calling the function, right? In the scope of these templates, at the very top level, so like maybe right here, the dot, every time you see dot, just think of the word this. And when you think of this, it's referring to whatever was passed into this template when it's executed. So in this case, this dot is this name variable, which in this case is just a string. If you go to, again, this template, this dot is just equal to this number 1. Now this template, the dot is equal to this top level data I passed in, which is this slice. But what happens when you go into something that does like an iteration like this, within the context of this action, so this range, each iteration, this dot is equal to whatever the value is that we are currently evaluating. So the first time that we are going through this range iteration, this would be equal to Donald. On the second iteration, it would be equal to Bob, and then on the last one, it'd be equal to Brody. That's probably the most straightforward way for me to explain it. If we were interacting with a struct or something that had properties on it, so like instead of this being strings, if these were structs that had properties, you could say like dot and then the name of the property to get the value off of it. That's probably the most straightforward way for me to explain them. Now, here's something super neat that you can do with the templates that I don't think a lot of people realize you can do this, is you can actually inject additional functionality that isn't normally present when you're processing the templates. And you do that with something that it uses called a func map. So if I go back here and let me see if I can find it. It is down here somewhere, a func map. Okay, yeah, type func map. So you'll notice that there's a function on the template type here called funcs. It says funcs adds the elements of the argument map to the template's function map. There's like a base set of functions you can call in the when you're processing a template, but there's not a lot of them. This essentially allows you to do is to inject additional functions that you can use to process the text. And it says that the functions have to be, they have to either return like 1 value or 2, and then the second value always has to be of type error. And what happens is if the function actually returns an error, when you call like execute will return that error. So let's add something to this this template that doesn't have by default. Let's give it the ability to uppercase all of the strings if we want. So we're gonna have we're gonna use the exact same template string, okay? With the exception is, let me paste this back down here. We're not going to just do dot. We're gonna pass in a function that we're gonna call toUpper, like that, okay? And this may not make a lot of sense right now, but it will very shortly. Okay, upper. So we're gonna say template equals template.must template.new funcs, and now I'm gonna call, is it func? Funcs, yes. And we have to pass into it a map. And let me make that map real quick. So I'm gonna call it func map equals a map of strings, and I'll just say technically they can be whatever. So I'm just going to do that like this. Make sure it's not complaining at me. Okay. So I'm going to say that to upper. Oops, that's not how you spell upper, Donnie. And I'm going to say there already is a function in the Go standard packages to do this. I believe it is strings dot to upper. I believe that's what it is. Let me do this. I believe that's what it is. Yeah. So now we're going to say funcs is equal to this func map, and then we're going to call parse, and we're going to pass in our template string like that. Okay. And we're going to throw this away. Is equal to template dot execute OSSTD out, and we're going to pass in our names again. So what this should output is almost the exact same thing as before, but all the names should be uppercased. Keep in mind the uppercasing stuff is not included in the base set of functions you can normally use in the template package when you're processing templates. So if I run this now, you'll see that the second set, they're all capitalized. You've injected additional functionality that wasn't there before. This is super convenient. I did this once for a project that I sort of just did as an experiment. In fact, that's the last example I'm going to show you is a excuse me, an adaptation of what I did once to essentially generate code for me. So I'm going to go to a entirely different file. I think I called it structs.go. Yeah. So this is we're gonna pretend that I have obtained some data somewhere. And this data is of this structure. It has a name, a description, and some fields. And a field has a name and a type name. And what we're going to do is we're going to use this data to generate Go struct definitions for us. So you see I've already defined some data here. You just have to pretend that I got this from somewhere else. In practicality, this example is based off of when I used a web scraper to scrape a service's API docs to get the information about their the shape of their data types they either expected in arguments or in responses, and used it to just spit out all of these struct definitions without me having to do it by hand. So we'll see this first one says it has a name called server, and the description says details about a server, and it has 3 fields: an ID, that's an int; a URL, it's a string; and active, it's a boolean. Okay. We have another one, channel. There's a description, has 3 fields, and then we have a role. It's kind of sort of based on like like Discord's way it's laid out, more or less. And then we have our template, and you'll see my template. You can actually load in a file instead of just like parsing an actual just like string verbatim. So let's open that up, shall we? See, split struct.templates like this. And here is the template. And you're going to see a couple of other things I'm going to explain too. So here's our dot. Now keep in mind, I am passing in a slice. So this top level dot will be the slice. So I'm ranging over the slice. And then since the things I'm ranging over, or the things that are in this slice are structs, the dot here is just whichever particular struct I'm looking at, and I am referencing a property on the struct. And you'll see that I am assigning the description property as the comment for the struct. And then we have type, and then the name will be the actual name of the struct, and then you can just have one set of curly brackets, and then it won't think it's like a template syntax. And then again, I'm ranging over the fields because the fields in the data struct is itself a slice, so I can range over it and reference each one of those. You'll see there's this little like minus mark at the end here. This actually has significance. If you have in your open brackets like this, if you have a minus sign with a space, in this case preceding, and in this case it'd be proceeding it, this will trim all the white space to the next section, because you'll notice before when these printed out down here, this was basically kind of like verbatim the way it was. But you can use this little minus sign syntax to like trim white space either before or after your text that's being generated. And then you have the name, which is the name of the type, and then type name, which is just whatever type I said it was. And then, and we're done with this range, then we're done with this range. So surely this doesn't actually just spit out code for us. That'd be crazy, right? So if we go down here, you'll see that I'm creating a buffer for me to write the process template into, because again, remember, this can take anything that implements io.writer, and bytes the buffer type from the bytes package does do that. And then interestingly enough, that little neat utility that Go can use to format your code? Well, you can actually reference it in the code itself. It's in the package called format, and it has a function called source. And in source, you pass into it a slice of bytes representing your source code, and it gives you back a slice of bytes representing the formatted code. And you'll see down here at the end, I typecast the slice of bytes into a string so I can just print it out. So let's actually run that and see what it does, shall we? We're going to do go run structs. That's not how you spell structs, not structs.go. And would you look at that? You have basically pre-generated Go code. Nice, right? Now this example was pretty not really that important, but the example that I was telling you about that this is based off of, it was actually Mixer's API. Rip Mixer, by the way, because I got interested in it whenever Mixer yoinked Ninja, and I noticed they had really well documented API documentations, and I managed to write a web scraper that scraped specifically the all of the information about their types they use in their API. And holy shit, thank God I did that, by the way, because there was about 157 data types in their API docs. Imagine going through and writing the type definition for 157 structs. No, thank you. I basically wrote this in a way that it took all that information, ran it through a template, not dissimilar from this one right here, but just a little different because there was some constants and stuff too. And boom, I got 157 structs in minutes rather than me sitting here for hours doing it. Granted, I had to clean some of them up because there were some inconsistencies in the verbiage they were using to describe certain parts of their data types, but just imagine how much time I saved from doing that. So keep that in mind. If you're going to write a Go package, and it's a Go package for an API, and they have their types for their API very well laid out in their docs, why write the things out by hand? You could just scrape it with a web scraper and just spit out all the boilerplate code so you can get to actually writing the actual functions and stuff. So yeah, there you go. That's all I have for you today. Just to make you aware that Go actually has a really nice template package built into it, and it makes it very powerful and very convenient to use, and also very extendable because you can pass in that func map that allows you to inject functionality into it. If you liked the video, be sure to drop me a like, subscribe, or follow. It depends on wherever you're watching this at. Share if you think anybody else would be able to make use of it. If you'd like to support the channel, support these tutorial videos, I should have some links wherever this is posted. Again, you don't have to support it all, but I would greatly appreciate it. And with that, y'all come on back, and I'll see you next time.